Hello, everyone. Welcome. Welcome to the very first HTAP Summit. Before we get started, I want to thank you. Thank you all for coming. Thanks to everyone who made this happen. Finally, this is the first HTAP Summit ever. Let me introduce myself a little bit. I'm Max, CEO of PingCAP. You know, I was an engineer, and I'm still coding a little bit. In my career, I spent lots of my time, doing lots of stuff related to database. I was kind of like really frustrated about the database. I always started my project, my service, my application from NoSQL database, like MySQL and Postgres. It works well until I need scalability. Then I tried something different. I tried, NoSQL solutions, Cassandra, HBase, and so on. But when I, built some a little bit more complicated business logic on top of those NoSQL solutions, I start to really miss those good old SQL. So, after years, work around with those complex solutions, I was so disappointed about the database. But don't get me wrong, those databases are really good. I just want to, spend more time, enjoy my life, not work around on those really complex solutions. So finally, I decided to create a new database, which is TiDB, an open source distributed database with horizontal scalability. It is a cloud-native database. Since we gather here, I cannot help thinking about 30 years ago, 40 years ago, when we used database at that time, there is no big data, right? There is no OLAP, right? It's just the SQL. It's pretty simple. But now, look at the world. It is so complicated. So why it's so hard to get a single database with scalability, with SQL, with transaction support? I was wondering why it is so hard. I got some of my answers. But before we go to those answers, let's spend 2 minutes to talk about the word HTAP. So, for many of you, HTAP is pretty new concept. So, what is HTAP? What does it mean? What's the relationship between HTAP and OLAP? What's the relationship between OLTP and HTAP? What's the best user scenario for HTAP. In 2014, for the very first time, Gartner bring out HTAP to the world. If, imagine if there is kind of thing make those OOTP and OAP work together. Just imagine, what kind of world would it be? These kind of questions are really hard. It's really hard to tell what is HTAP. It's hard to explain. Is there any specific scenario could just be fit for HTAP, but other solutions it's not possible to solve the issues. It is so hard for me to explain for a long time until we build an interesting demo. Let's take a look. As a huge fan of open source, I always want to understand open source deeply. I'm a GitHub user. I want to understand every GitHub user. I want to understand every repository in GitHub. And I also want to understand every trend of GitHub. So let's look at this interesting demo.
The OSS Insight website captures GitHub data changes in real time. GitHub events are triggered by user actions, like starting a repository or pushing code. Currently, there are more than 5 billion GitHub events, and the number is growing each second. We visualize this dynamic process through this chart and a live page where we can see the data dancing. OSS Insight takes us behind the data to more deeply understand what's going on. For example, we know developers are coding actively, but which group is the most active one? The live page shows us what's happening on GitHub right now. In the past hour, TypeScript developers have been working the hardest. We can also see the most active repositories and developers in the last 24 hours. Impressive! Let's analyze an open source repository. We'll choose Kubernetes. The repository overview shows the number of stars, issues, and commits. OSS Insight also provides query statements and execution plans. Click Show SQL to view the execution plan. Each SQL statement uses an online transactional processing index. That's why this statement can return results so quickly. GitHub can tell us who has contributed to Kubernetes, but OSS Insight can tell us more, like where they're from and who they work for. This world map locates the people who are interested in Kubernetes, who created issues, and who contributed code. Developers in China are most interested in Kubernetes, while developers in North America contribute the most code. And we can see some big names too, like Google, Microsoft, Red Hat, and Tencent. These charts are derived from the GitHub users table, which is frequently updated. Let's look at the execution plan. If we join the GitHub events and GitHub users tables, we get a multidimensional analysis, where the contributors are from, and which companies they work for, rather than just the code. If we want to drill down deeper, we can create a playground to write SQL. Let's find out who created the first Kubernetes pull request. We can put together some simple filters. We can see that the author is drawn silly by the Google Cloud Platform. In business, we often need to focus on the most active head users or best-selling products. OSS Insight has similar requirements. Its homepage shows trending open-source repositories. We can see the most popular repositories in the past 24 hours, week, month, or 3 months. We can also filter repositories by programming language. Let's look at the SQL execution plan for trending repositories in the past 24 hours. Here, the Database Optimizer only uses the row store engine. Let's switch to the past 3 months tab. The SQL statement is basically the same, only the time range is different. Actually, for the past 3 months tab, the Database Optimizer decides to use both the column store and row store engines. That means for different parts of an SQL statement, the Database Optimizer intelligently decides to use the row store engine, the column store engine, or both. We've only touched on the basics of what OSS Insight can do. There are many more interesting facts hidden in those 5 billion GitHub events. Try us and gain your own insights.
Wow, that was pretty cool, right? I can watch it for a whole day. So what can we learn from this demo? First, there are lots of data. More than 5 billion of records, and the dataset is still growing fast. And also, there are some, as a web service, there are many users using OSS Insight every day. So the infrastructure needs to handle that challenge. And also, we can see there are some unpredictable queries. We can query a specific record, a specific time range, a specific GitHub users, a specific repository, any trend you want. So imagine, what kind of database should you choose? Billions of records, maybe you started to thinking about a sharding database, plus streaming processing, plus a data warehouse, and a data lake. So what kind of tech stacks will you choose? How many engineering resources do you need? How long will it take to build a website like this? Or maybe, I'm not building the same thing, I'm building something different. I'm building something really hot, like a Web3 service. This is a real example, KNN3, a Web3 user-centric solution. Let's take a look.
KNN3 is a Web3 user-centric DataFi solution that allows DApp and smart contracts to interact with multi-chain data. With KNN3 Network, Web3 analysts can dive into specific address or transaction and also explore the relations between it with many other events, transactions, assets, addresses, and social relations, etc. For example, if we search stanny.lens on Mashmesh, we can see the follower and following status of her/him. And on the right side, we can open all the information with follow, following, NFTs, tokens, lens follow, events, and governance. We can also dive into one of her/his lens connections, then alistair.eth, and see her/his connections and assets. With affluent cross-chain fresh data, trending analysis on transactions and events has also been made possible. Last but not the least, All the analyses of on-chain transactions, trends, and connections with people are real-time.
Again, what kind of tech stack will you choose to build a similar Web3 service? Is there any easier way to build a web service like this in a week? What kind of architecture in your mind? Let's take 5 seconds. Imagine what kind of architecture in your mind. Here is the actual architecture. How do you feel? Amazing? So simple, right? A single database to handle everything. So you might be wondering, a single database to handle both transactional workload and analytical workload, is it possible? Comparing this architecture with that architecture in your mind, that's why we need a HTAP database to handle all these challenges, to hold all this data, to provide a real-time online data service. So, what if we put the database in the whole flow? Are there any common things, common patterns? So we have inputs, and we have outputs, and in the middle, we have data processing technologies. We have a database to handle everything. If we zoom into the input, so what's the challenges of the input? We have multiple sources, right? Let me introduce another example. Here is a decentralized financial service from a leading Web3 player. There are many public blockchain data. Web3 is really hot. So we can build a single database, right, to pull in all of those public blockchain data in just a few months. The company pulling from 30 to more than 100 public blockchain into a single database. And the data volume has increased from tens of terabytes to more than 100 terabytes. And it's still growing fast. And also, the business model requires concurrent reads and writes. So what about the outputs? What about the online data service or online data services? Imagine if we are building a customer success platform. If you are running a customer success platform, you want your customer happy. Well, customer success. You will facing some of those things, challenges, such as different users use different softwares. Some of them are using Salesforce, some of them are using Zendesk, and even modern users use email directly and Excel. Trust me, they exist. Use this kind of modern tools to check, to trace their business data. And for the output, different customers have different definition of customer success. So for every enterprise company, when we talk about culture, yay, customer success. But what's your definition of customer success? Ask different people, you get different answers, right? So if you are running a platform, you need to have a product to provide that kind of flexibility and customization features for your customers to define their customer success definition, to define their queries, to define their workflows, to define their templates. So we need to provide a stable and scalable online data service to help our customers, to help their customers. There are some challenges, really, really hard. And I'm really glad Andy is here, and he will share his experience this afternoon to introduce those challenges. For those, if you provide this kind of different sources, you need to join across different sources. Usually that leads to really slow queries. And since you provide the flexibility for your customers, there are some unpredictable queries. We just showed the demo OSS Insight, right? So the user could just write SQL and run on your dataset. We need to provide that kind of flexibility. It's unpredictable. So how do you choose your database? What kind of database can face, can match those requirements to provide that flexibility, to provide the ability to face those unprediction? And still, you need to keep it stable and scalable. As your business is growing, your data is growing, all of this will be really big challenges. So go back. Let's take a look at the data processing. Wow. I believe in your mind, this is kind of, beautiful architecture, amazing architecture. This is kind of like, I am a good engineer. I'm a best talent in the software domain, right? It's kind of like, it is amazing skills for me for a long time. Hey, I know how to sharding a database. Hey, I know how to stream it and then combine it somewhere else. Hey, I know how to join different data with my code. Now, not depends on the database itself. I can write my own join. Right? It's kind of wow, amazing skills because how many join skills there. You can do left join, right join, inner join, so much joins. So how complicated can architect be? We invented so many great technologies, so many amazing products. But still, I just show you a few examples. If we are trying to build those kind of services in a week, it's so complicated. But does it to be this complex for all of our use cases? What if? What if we have a single database, can handle both transactional workloads and analytical workloads with scale? Just imagine. Whew. That suppose what's HTAP database to do. That's why we are here. We all know the reality. Reality bites. Two months ago, I talked to a Gartner analyst. He told me he had been so excited about the concept of HTAP, but none of the products fulfill his expectations. So, imagine, if I'm talking about OLTP databases, there are some names in your mind, right? If I'm talking about OLAP databases, data warehouses, there's something in your mind, right? But if I'm talking about HTAP, is there any names, any products in your mind? HANA? Cool. Who is using HANA? Wow. I see no one. This is actually a perfect example I will talk about a little bit. Be patient. Thank you. It's dead. It feels like HTAP is dead to him. It's just like a dinosaur. Right? Dead for years. I think it's close to 10 years for HTAP. So this is the picture I posted on Twitter. I hope you enjoy it, just for fun. But seriously, why did HTAP dead? So what happened? In 2014, when Gartner coined the term HTAP, it is described as a single node in-memory database. We just talk about HANA. I beg your pardon? Sorry. Oh, my voice? Oh, sorry. Thank you. I want me to speed up. I will. Thank you. I'm so talking guy, huh? So, sorry. To make a in-memory database really work, at least you have some assumptions: unlimited memory or ultimate CPU power. And of course, you need really huge bandwidth for network. 15 years ago, we dreamed we will have really big memory. We dreamed that the capacity of memory is close to hard disk, and we dreamed the cost of memory is close to disk. But the reality is far from it. We still remember, memory is the new disk, right? We still remember that description, that claim, right? And similar story happened to CPU. As we are here, right? Computer History Museum. We all know what happened to CPU. We all know what happened to Moore's Law. Of course, there are many amazing hardware industry companies are working on it. We get more and more cores for a single node. But still, the data creation speed is much faster. So, a single node cannot handle those that much data. But if we kind of rethink about everything, if we rethink about those assumptions out of the box, we can still get as much memory as we want. We can still get as much CPU power as we want, right? From the cloud, it's already there. It's just not possible to get from a single box, from a single server, right? Therefore, distributed database is the only way out. So the cornerstone of HTAP is scalability. Woo. Simple as that. A single box cannot just handle that size, that volume of data. You probably see different names in different places, from Gartner, from Forrest. But the trend is quite clear. HTAP database as an important category is getting more and more attention from users, from analysts, from vendors. Especially in last 6 months. Well, Google launched TiDB, Snowflake launched Unistore, and even for Oracle, released MySQL HeatWave on AWS. Can you imagine, right? That's amazing. In just 6 months, what happened next? Well, you probably think, is it too good to be true? I don't buy in, right? So HTAP as a single-stop solution, as a one-stop solution to handle all of these issues, is it possible? Don't get me wrong. I think this is the positioning of HTAP database. As a scalable HTAP database can handle terabytes to petabytes of data. For those data, not used as an online data service. It should be handled by data lake or lakehouse. So what kind of design principles should we use to design a HTAP system, to design a HTAP database? I think those are scalability, freshness, simplicity, and cost effectiveness. Since we are putting more and more data into a single database as an online data service, you need to consider the costs. You need to consider the simplicity. Right? You don't need to worry about the scalability. You want simplicity, right? So if we take one more step, is there any reference architecture can I use to implement a HTAP database? So here it is. From the developer perspective, I don't want to know any details about the database. It is handled by the smart optimizer. The optimizer should have the ability to choose, should I get a specific record in the row store, or should I do aggregation on the column store? Or even better, should I combine both? For a single query, you get some of the data from row store and some of the data from the column store. So I can combine them together. Since we get all of the benefits, we have design principles. We can implement it. So I believe in the next 3 to 5 years, all of the distributed databases will be HTAP databases. But can we bring you some, real feelings? Like it is 3 to 5 years later. Let's make it real. Wow, I've been waiting for this day for years. It made me feel like, this is probably that day Steve Jobs released the first generation of iPhone. Still remember the question mark? What happened next? So we'd like to hear from you. We bring HTAP serverless forward to beta release today. So you can try it right here, right now. We have prepared a booth experience. And also, if you bring your laptop, we have some great workshop sessions. So enjoy it, have fun, join us, make HTAP real together. Thank you very much.